Okay, number 16. The following output, again from Minitab, presents the results of a hypothesis test. This was a test of, so I'll do the steps here. Step 1, population mean equals 43, less than null hypothesis. And the alternative hypothesis was not equal to 43. Okay, so they're asking if we reject the null hypothesis at the alpha equals 0.05 level. Now I can show this with the traditional method and the p-value method. I will say I'll show the p-value method first because the p-value method works really well when we're talking about this Minitab output. It works really well. Remember, for the p-value method, if the p-value is less than or equal to alpha, reject the null hypothesis. If p-value is greater than alpha, do not reject. I can't write, I can't spell. I don't know what's going on here. Do not reject the null hypothesis. If I were doing this problem, I would use the p-value method for this, because this is all you have to remember. This is not on your formula sheet, but you have to remember this, yeah? So we're given the p-value. P is 0.007. I'll just go 3 decimal places, right? And alpha is 0.05. Which of these is, I'll go 3 decimal places. 1, 2, 3, 1, 2, I'll add a 0 to go 3 decimal places. Which one of these numbers is larger? Definitely alpha. Right, 50 hundredths is less, 50 thousandths is greater than 7 thousandths. So the p-value is less than alpha. So what we do, reject the null hypothesis. And we're done with this question, right? The traditional method is going to take a bit longer because we have to find that critical value for 0.05, right? 0.05. Not equal to, so this is two-tailed, yes? Remember, less than will be left-tailed, greater than will be right-tailed, but does not equal to is two-tailed. So two-tailed, 0.05. Let's go to our formula sheet, go down to the t distribution. Two-tailed, 0.05. Two tails, 0.05 is our alpha. That z critical value is 1.96. So this is 1.96 and negative 1.96, right? And then we have to calculate, well, we don't have to calculate the z-test value because we have it. Z equals 2.67. Now 2.67 is clearly in this region, in this rejection region. It's greater than 1.96, right? So since 2.67 is in the rejection region, what we do, we reject the null hypothesis. So the same conclusion, it just takes a little bit more to get here using the traditional method than the p-value method, especially when you have z and you have p given to you. You don't have to do any calculations or anything. But to make the traditional method work, you have to find those critical values to determine that rejection region, to see if this test value is in that rejection region. Okay?